in this video, we are going to talk about trigonometric ratios. Did I just say trigonometric ratios? Wow, mind-blowing. I can easily see some people in the audience, they are really scared. But trust me, there's nothing to scare about trigonometry. It's a very simple thing that we can easily master. So what I'm going to do, I'm going to try my best to give you a very simple explanation, and at the same time I will go through really slow and help you understand what a trigonometric ratio is. So let's first spell it like what we are talking about today. So we are going to talk about trigonometric ratios. Now, as you know, trigonometric ratios are basically ratios. Can you see? This is a ratio. And when we talk about ratios, we are talking about ratio of sides of triangle, because trigonometric means what? Study of triangles. So when we talk about trigonometric ratios, we are talking about the ratios of the sides of the triangle, because trigonometry is basically the study of the triangles. Pretty simple, huh? So like, it's not a very scary thing, but like most people, they are scared when they hear this thing, trigonometry, because that's how we have explained our kids or our students, saying that, you know what, trigonometry is very difficult. But trust me, it's a very simple mathematical concept that anybody can master. So don't worry, we will do really good during the lesson. So first thing first, what I'm going to do, I'm going to draw a right triangle, and we all know what a right triangle is, right? So this is my right triangle. As you can see, this is my right triangle A, B, C, and if you remember, this is the symbol of right angle. And we already talked about the symbol for the right angle in our previous video. So when you see this symbol, this means it's the right angle. Now, if this is the right angle, then the name of the side opposite to right angle is hypotenuse. Hypotenuse. And if you remember, C is the vertex, so the length of the side opposite to the right angle is basically lowercase or a small c. In the same way, length of the side opposite to A is small a, and opposite to B is small b. What I'm going to do, I am going to take my angle A as my reference angle. And if I take A as my reference angle, then the side opposite to angle A is basically small a. Name of this side will be opposite. This is the way it is. Side opposite to reference angle is opposite. That's the name of the side opposite to A, or opposite to reference angle. And the side next to reference angle is basically this side, and the name of that side is basically adjacent. So as you can see, I have my right triangle ABC with C as a right angle, and the name of the side opposite to right angle is hypotenuse, I am taking my angle A as my reference angle. You are free to take B. But then, as you remember, when you take the reference angle different, opposite and adjacent, they interchange. But hypotenuse does not change. So, if I am taking A as my reference angle, then the side opposite to reference angle is opposite, and the side next to reference angle is adjacent. Now, let's talk about our first trigonometric ratio. So my first trigonometric ratio is sine A, and sine A is basically opposite over hypotenuse. And as we can see, our opposite is BC, so I will write BC over my hypotenuse is AB. So I will write BC over AB. And if you look closely, BC is my lowercase a, so I will write lowercase a over AB. AB is my lowercase c. This is A over C. So if I write sine, I can write sine A is equal to A over C. And again, you can see A is side and C is also side. So basically sine is a ratio of opposite over hypotenuse. And that's the reason why we call it trigonometric ratios. Now, let's talk about the second trigonometric ratio, which is basically what? Cosine of A, and cosine is adjacent over hypotenuse. And if you look at the triangle, adjacent is AC, so I'm writing AC over my hypotenuse is again AB, so I write AC over AB. And my AC is, if you look closely, my AC is lowercase b, and my hypotenuse is still the same, which is lowercase c. So I can write cosine A is b, lowercase b, over c. And again, this is the ratio of adjacent and hypotenuse. My third trigonometric ratio is tangent A, and tangent is opposite over adjacent. And if you look at my triangle ABC, my opposite is BC. So I will write BC over my adjacent is AC. So I will write BC over AC. And if you look closely, you can see my BC is opposite, which is lowercase a, over AC is my adjacent, which is lowercase b, right here. So I will write A over B. So my tangent is, I will write tangent of A is A over B. And again, this is my trigonometric ratio. And the reason why I'm calling it ratio, and I keep saying the same thing again and again, because we are finding the ratio of the sides of the triangle. So this is how we will define the trigonometric ratios.